Hi, I'm Susan Glenn. We're going to be talking about climate diagrams. I'm basing this on the book Ecology, Concepts and Applications by Molles and Sher. And we've already talked a little bit about biomes and with the distribution of average temperature and average precipitation around the planet. What we're going to be looking at is a very simple tool, the climate diagram or the climatograph or climatogram, which lets you look at the temperature and precipitation, just not the annual average, but actually the monthly averages. So you can look at seasonality because we know that depending on average temperature and average precipitation, sometimes you have a choice of different biomes at a location, and the seasonality of precipitation and the temperature fluctuations around the mean become important. Does the temperature drop below freezing at a certain time of the year? Is there a dry season in precipitation? A couple of other factors that end up being also important are going to be soil compositions and altitude. So diagrams have a standard structure where we have temperature on the left vertical axis and precipitation on the right vertical axis. And they are scaled so that as the temperature increases, you're going to have on the one axis, the temperature, a 10-degree increase in temperature on that axis is going to be the same height on the graph as 20 millimeters of precipitation. And that is because for every 10 degrees Celsius increase in temperature, plants are going to need 20 millimeters more water in order to survive and do their photosynthesis. So you know on a hotter day, you need to water your plants more outside because on a hotter day, they are going to be having more water evaporate. So the relative position of those two lines reflect water availability. If the temperature line is above the precipitation level, then you know you don't have adequate amount of water for the plant to grow. Here we're going to plot, make our own climatograph. So what I'm going to do across the x-axis is I'm going to put the months of the year. We have January, February, March, April, May, June, July, August, September, October, November, and December. The way these months are put is the way we normally put the months, where you put the summer months are going to be in the middle of the graph. In the Southern Hemisphere, in your textbook, they will often start with, instead of starting with January, they'll start with July. So in the Southern Hemisphere, they would put July, August, September, October, November, December, January, February, March, April, May, June. And so when you look at a climate diagram in your textbook, they'll all have sort of the summer area when the sun is directly overhead, that hemisphere in the middle of the graph. So pay attention to what months are down there. So on the left vertical axis, we put temperature. So we're going to have temperature in degrees Celsius on that one. And on the right one, we're going to have precipitation, which is going to be in millimeters. So we obviously, in your science class, you're using the metric system. And so a 10-degree increase in temperature is going to be associated with a 20 millimeter equivalent of precipitation. So if I'm showing my temperatures, let's say I'm starting on this axis at some place that's not going to have a cold winter. So we're going to have it starting at 0 at the bottom, 0 Celsius, the freezing point, and then we're going to have 10 degrees and 20 degrees Celsius. Well, then I would also start with 0 millimeters in precipitation, and then I would put 20 millimeters and then 40 millimeters for the same distance on the graph. So if I have in January, I have a temperature that's going to be 10 degrees in January. And if I have at the same time, if I have precipitation that is 40 millimeters, precipitation is higher than temperature, so I have more than enough rainfall for the plants to grow. So let's say I plot my temperature points throughout the year. So they get very hot in this particular place and then they start to drop. So maybe I get something that kind of looks like this for temperature. And then for this location, let's just say the rainfall is constant all year. So my rainfall goes across like this. We can see there's a certain time of the year where the rainfall line is beneath the temperature line. And so we have this period of drought where it's too hot, there's not enough rainfall for the plants to grow that time of year. So you can see at a glance that we have a drought period, whereas the rest of the year we have more than adequate amounts of rainfall. You'll also notice in the climate diagrams in your textbook for areas where the temperature drops below freezing, plants can't grow then because the water's all frozen. They need water for photosynthesis. They need photosynthesis for growth. So if it drops below freezing, you can't get any water. The plant is unable to grow. So they will also show you in your textbook, they will actually highlight the growing season by sort of coloring in those months with a red color. And on here, I can do that with maybe with a highlighter. I'll just do it with orange so you can see. There we go. It's not really a highlighter. Ah, well, that didn't work. That was an eraser. Here's my highlighter. There we go. I'll put my months back here. Sorry about that. So they will highlight the months that have the adequate amount of temperature for the plants to grow. And this obviously is a tropical area that has a summer drought in it where they don't have adequate rainfall. So this is probably going to end up being a tropical, because it's hot all year, but dry because of the dry season forest. Or it could even be a tropical savanna because of the dry season. Okay, this is a much nicer looking climate diagram and basically showing you that you've got the months across the x-axis. They've highlighted the growing season months. Those growing season months that they've highlighted are when the temperature is actually above 0 Celsius, which is 0 Celsius is going to be your freezing point. So the plants cannot really grow until you get above that. When we have an area we call a temperate area, a temperate biome, we're talking about areas that have a season during the year where temperatures have dropped below the freezing point. And in this particular case, we can see that the precipitation line has fallen above. So we got the blue line is precipitation, is fallen above the line for temperature. So there's always adequate precipitation. This example shows you an area where we've got high amounts of precipitation all year, and it's got so much precipitation they have adjusted the scale. So pay attention to the scales on these diagrams in your textbook. So we're going by 20 millimeters up until we get to 100, and then that same distance now where they've got a darker shading means that they have adjusted the scale. It would have been off the top of the graph if they didn't do that. And so we can see there's high precipitation all year. We can also see that there's high temperatures. So we're looking at temperatures around 80 degrees Fahrenheit or 28 degrees Celsius all year. And that is probably a tropical rainforest site. Here are two different desert sites. The top one is the hot deserts in Arizona. So we can see that it's always above freezing. We can see that the temperature never drops below freezing. So all year round, you're keeping your temperatures very hot, but there's never adequate precipitation throughout this for the plants to grow. And then the bottom one is a cold desert in Mongolia. And the cold desert in Mongolia, we can see that the temperatures drop below freezing for a certain part of the year. We've only got May through September is your growing season, which is shown at the bottom. And and though you have adequate winter precipitation, it's going to be in the form of snow. And so the only real time you're going to get growth of plants is in the early spring, is when that snow melts, and then you're going to have adequate moisture. Otherwise, the temperature line is above the precipitation line for the rest of the summer. So you'll get things growing as the snow melts and moistens the soil in the spring, but as it warms up, it's just going to be in a drought. So this is probably a desert, a cold desert, or could even be, depending on how much is grown in the spring, you might have a little bit of a very dry grassland there. There are more factors to be considered when we're looking at this large-scale changes in the biomes across the planet, and we will be talking about some of these additional factors, which include soil and going up in elevation. So join us for the next video. See you there.